Okay, sounds great. Hello, everyone, and thank you so much for joining in today. Today, we are going to hear from Supreet Suresh on using LLMs and generative AI for debugging scientific code. And specifically, we are going to see some demos of using GitHub CoPilot for debugging scientific code. Supreet, can you please move to the next slide? Before we start, I wanted to remind you all of the code of conduct. As usual, please be respectful to everyone. And if you've noticed any issues or any problems, please notify one of us, Tasia, Jessica, or me, and we'd be happy to help with that. Yeah, please be respectful and nice to each other. Supreet, can you please move to the next slide? Thank you. We are going to have another session of this workshop series. It's going to be on the topic of sustainability, energy use, and environmental impacts of using generative AI tools, both in the training phase and also using LLMs, using the prompts. And the speaker for this is going to be Pengfei Liu, and the session is scheduled for December 3rd, 2 to 3 p.m. If you've already registered for this series, you don't have to register again. Just wanted to advertise it for awareness. And with that, we are going to hear from Supreet on debugging scientific software with GitHub Copilot. Thank you so much, Supreet. Please feel free to start.
Yep. Thank you again. Can you hear me? Okay.
Yep.
Okay. Hi, everyone. My name is Supreet Suresh. I'm a software engineer in CISL ASAP. And first of all, I would like to thank Megan and the team for giving me this opportunity to present in this workshop. Yeah. So today I want to talk about how we can accelerate and ease up the process of debugging a scientific code with the help of Copilot. From the previous session, you guys have attended, like you have understood how to use Visual Studio Code, as well as Copilot within VS Code. Today, we'll be using the same setup. We'll not be using the Vim or Emacs in this session. We'll look at some of the common issues that we encounter in our daily life, and some of the problems that I'm demoing in this presentation might look simple, but it's just for the demo purposes, and you can do the exact steps or the similar steps to debug any complex issues as well. So with that, there are a few experimental experimental features that GitHub Copilot have introduced more recently. Will not be covering them in great details, but you can always read upon and try to use that. It makes life simpler. Now, let's look at how my experience has been working with Copilot to debug some of the codes that I've been working with. So first of all, let's take a look at some of the traditional methods of debugging that we generally use. So when we get an error message, we try to actually look for the error message and then try to figure out whether it's a compiler error message or a runtime error message, and we try to understand that error message, and then we start debugging or fix the problem. Sometimes if we don't understand the error message, we use Google or any kind of blogs like Stack Overflow or forums or documentation to kind of figure out what the issue might be. Like one of the next one is one of the most widely used one. It's the print statements. We put print statements all over the place and then try to debug the code. And sometimes we use our, if you're professional enough, like use kind of debuggers to figure out what the issue might be. And you might have already had like unit test logging. If you don't, like kind of harder to debug. So these are some of the traditional methods of debugging our code. So today I'm not gonna argue against it. Like, these are well-established methods. I'm just gonna propose that CoPilot makes easier, faster, accurate to debug with these traditional methods. So CoPilot is kind of most effective when you pair with this traditional debugging methods. Copilot can give you kind of a summarized view of information that you are looking for. So as I look at this, with these traditional methods like that we use with Copilot makes it faster, more accurate. For example, I don't have to scrape through the entire internet or go down the Google rabbit hole of finding information about a bug or some kind of documentation. Copilot gives you a well summarized, detailed information and instruction along with the code snippets to kind of figure out your issue and debug the issue errors that you have. With that in mind, now let's look at some of the common errors that we encounter in our daily lives, in our scientific codes, and how we can debug that. So actually, I asked Copilot to kind of classify some of the error types, and this is what came up with. So it can identify and help you solve all these kinds of problems. So the first one would be the syntax errors. So these are kind of relatively simple to kind of debug. Even if you use a IDE like VS Code, you can actually use the kind of a linter, or the IDE can point out some of these incorrect syntaxes or typos that you have in your code. But Copilot can be robust and help you debug more complex syntax errors. The next one is the logical errors. These are kind of really hard to debug unless you have knowledge about the domain or what the expected output results should be. These are kind of hard to debug. If you have if you have an equation and you have implemented that incorrectly, then unless you have a very specific domain knowledge that it should be right, like you know what it should look like, the answer should look like, it's kind of hard to debug. And even the off by one errors, like when you're doing some kind of hello exchange, you're messing with the index, and it just messes up the whole code. So these are kind of hard to debug errors, but with Copilot, it can make it easier to debug them. And we'll look at examples on all of these things, or most of the things. The next one is the runtime errors. So we have seen quite a lot of seg faults in our code, whether it could be because of a null pointer or pointer dereference, or divided by zero, or array out of bounds, which happens more in my case. So these are kind of relatively hard, but with debuggers, it makes it simpler. But with debuggers along with Copilot, it makes it even more simpler to debug these kind of errors. And then we have the compilation errors. You change a compiler version and you get some kind of errors. You can actually ask Copilot for help with these things, whether you're trying to do an operation between objects of two different classes or types, or even like you're missing some kind of dependency when you're building a code. You forgot to load a module. So that happens quite a lot. So you can actually debug those kind of compilation errors with ease as well. And at the bottom, we have some kind of like few more issues. Like I'm just calling these errors, the top one as errors and the bottom one as issues, because the issues comprised of, like, it's a broader term which comprised of errors as well. So CoPilot can help you detect some of the performance issue, although my experience hasn't been great with this performance issues, figuring out performance issues, especially for GPUs. But it can do some of the basic things that you might kind of expect. For example, checking the data layout is correct for the language, or checking for the memory leaks where it's happening. The next one is like the configuration issues. Like when you are running big scientific code, you might want to preserve some of the cycles by not running the computation if your configuration is wrong. So it can help you set up some kind of assertion or logging to kind of check whether your configuration is right, and also it can help you set up the whole environment. If we have time, I have an example on how you can set up this environment for a new workflow that we can go through. But yeah, it can also help you detect concurrency issues, like if you are working with OpenMP or OpenACC, like it can check for race conditions or deadlocks in your code. And of course, it can help you with the integration, like API mismatch. Suppose you are using a library and you are passing the wrong thing or in the wrong format, it can help you serialize and deserialize those variables to match for the API that you're using. And of course, the security issues, which personally I haven't used much, so I don't know enough to talk about that, how it can help. Okay, so in today's demo, we are going to look at the highlighted parts. Depending on, like, I had a 45 to 50 minutes of time, so these are the examples that I could come up with for that time. Yeah, we're going to look at these highlighted parts for today's session. So for the demo, I wanted to use some real code, not some toy code like a matrix multiplication or some kind of example like that. So, but when I was actually thinking of which code to use, I couldn't actually come up with any of the codes that I am working with because these are really big. And if I try to build and show an error, it would take like 5 to 10 minutes just to build the code and count the error. So instead, what I've done is I've selected a few code snippet from the big codes. For example, I have extracted a kernel or a function from the MPAS DICOR. Of course, using CoPilot, I've extracted this function, which I can actually run very quickly and demo the issues and ask CoPilot for help. I'll be using the mini weather app, which is developed by Matt Norman, I think from Allsurf. So I'll be using that, which has multiple languages as well as multiple framework. He has used multiple frameworks for to run the code with on both CPU as well as GPU. So it's kind of a robust code that I can use. And the next one, I'm going to show some how you can debug issues in large codes, but I'm not going to build them and show the whole process. I'm just I'll iterate through the process and then show it just with the source code how you can actually track down some of the things. So first one, I want to start off with the syntax error. So I have Visual Studio Code open and subsequent. I'll just switch to that as each examples comes up. So first, we're going to look at the syntax error. Oh, sorry. Yeah. So for this, I'll be using the kernel that I have extracted from the MPAS A DICOR. So in MPAS A DICOR, we have this compute vertical implicit coefficient. If I understood the scientific meaning right, I've extracted this small function into a standalone kernel, which I can actually build and run very fast. As I say, it's taking forever to build. Okay. So as I mentioned before, most IDEs can actually figure out most of the syntax issues. Again, some of the examples that might seem really simple issues in this demo, you can use the same techniques to debug complex issues as well. So first one I want to show is I want to introduce an error here. So let's say, actually, I have to go to the main. How do I make this go up? Okay. So let's say, just a simple error. So in Fortran, we have to declare all the variables at the very beginning. And when we have the declaration section as well as the execution section. So let's say I comment this out, the initialization. And I add this execution section in the declaration section. So previously I was able to build the code. Now let's try to rebuild it again. So I was hit with quite a lot of issues. So for a like experienced developer, it might seem simple enough. If you look at if you know Fortran and if you look at Fortran code regularly. But let's say for a newcomer, or even if you are switching to a new different language which you haven't mastered yet, so these kind of tools and these kind of debugging can really help you to understand the problem. So I think from the previous sessions, I think Brett covered some of the inbuilt, how you can ask the inbuilt questions here. So if I say at, it gives you some of the inbuilt functions, or even if I say help, it can tell you what it can do, or what CoPilot can do, some of the inbuilt functions that it can do. So with this, I'm just going to ask CoPilot to kind of explain what's on my terminal. So it read through the terminal and it saw an error. So if I read through this well-organized message, it went through the error and kind of gave me a summary of it. So what it is saying is, the Fortran standard has two sections, declaration and execution section. To fix this error, you need to move the variable declaration to a specific section. But let's say someone new who doesn't know how to actually declare it correctly, you can ask a subsequent question as well. So how do I declare the variables correctly? I just selected that. So it gave you an information on how to fix that error, as well as a code snippet with the corrected code in here, which you can actually just copy or move it over or insert into your code and run it. One thing I want to caution is, like, some of the times these code snippets have been wrong. Actually, I should say most of the time. So you should actually double check before you actually just blindly copying over it to your files, because it can introduce subsequent bugs in your code. So try to look through these code snippets, select what you want, discard what you don't want, or what might look like an error.
Supreet, there is a question in the audience, Brian, if you want to.
Yeah, sorry to interrupt, but I was just curious, is there a particular type of incorrect code that you've seen CoPilot produce more often that, like, people should look out for? like particular types of errors it would introduce?
Yeah. So I can give you one example. So let's say, okay, let me actually just comment this out for a second and uncomment this. So now the code is correct. Suppose I comment or move this implicit none. So in Fortran, we have to place this implicit none in a specific position. Let's say I move this. And let's try to rebuild this again. Now let me ask CoPilot again to figure out the error. So I can clean this. Now it is figuring out. Previously, when I was trying the same thing, it asked me to reallocate or allocate this in a really different way or move things around, but it couldn't identify the implicit none. But now it is kind of figuring out this thing. So yeah, so some of the times it kind of hallucinate and give you wrong thing to do. So you had to be careful just to blindly copy over the code snippets onto your code. You have to actually double check and use your best judgment to see if it is the right solution, if it is the right issue. Any other questions before I move on?
I don't see any questions in the chat. No, there aren't any other questions.
Okay. So yeah. So the next one I had on my list was to introduce a typo. Let's say I try to. I made a typo here. I want to rebuild this. Actually, let me move this back. Okay. So I'm just going to ask, without any additional prompt, I'm just going to ask to explain this. It actually build. This is still taking the old context. Okay, let me start a new. Okay. Now I have the new error. I'm just going to ask to explain it. You can see it can identify some of the typos that I might have introduced or writing. As I said, like the Visual Studio Code or any IDE can do this pretty well as well if you have all the linter and everything installed in there. But CoPilot actually can do it in a robust way, looking through all your workspace. So any questions before I move on to the next set of demo? Okay, great. So we looked at the syntax errors. Now I'm going to switch over to the logical error. As I said, logical errors are somewhat hard to debug, or really hard to debug if you're not a domain person. But CoPilot can help you make it simpler. For this, I'm going to demo some things with the Mini Weather app. So, so I have this. So I have the Mini Weather app here. So I'm just going to use the C++ version for this demo here. So let's say I'm getting some wrong result in one of the variables. Let's select a variable here. But state is the most important. So let's say I'm getting wrong. Wrong answers or tendency, let's select tendency. So I'm getting wrong results. So I'm just gonna ask CoPilot here. Tend variable as, okay, it's wrong. I can ask it to write a unit test. From the context, it kind of figured out 10 is a variable in this code. So we have all this code open. So it used the serial as a reference. So it created a new test for me. So I can actually include this test to kind of figure out what's wrong with the 10 variable. Or I can actually ask here, I know 10 is wrong here. So I can ask here. After this, I can invoke an inline chat. I can ask. So we write print statement with hand. So instead I can ask CoPilot to introduce print statement, print and for verification. So I don't have to manually write all these things. It can just help me add these statements all over the place. And I can run the code and look at the print statement there. This is just pairing the CoPilot with the traditional methods of debugging that we are used to. I'm just going to discard. Yeah, so we looked at the unit test and the print statement. So the next one is the debugger. So if you do use a debugger, it makes it simpler to kind of track down these logical issues. You can actually use debugger along with CoPilot. It makes it even more robust than just using the debugger. I kind of searched through it. This is an experimental feature in the VS Code. I kind of searched through it and I couldn't find any or how I can use how we can use the debugger, like the ARM debugger or whatever the name is called right now, the external debuggers with CoPilot just yet. So so as a first step, what we can do is, so there is this option called VS Code Start Debugging. I can just launch this. So it looked through my workspace and used some of the references, and it gave me a configuration which I can run to start the debug. I can just start debugging here. Since I have the configuration saved here, so I'm just going to launch it here. I'm just going to close this for a second. So I have configured, okay, actually before that, let me show inside the build, I have this launch JSON. This is where I have all the configurations saved. You can add multiple configurations to it. Okay, let's jump back. Let me start this debugging session inside VS Code. Okay, I haven't built the code, so it is not able to find the executable. So I have the CMake. It is building the code. Let me load the modules. Okay. Okay, great. So now I'm able to, since I built the code, I can actually launch the debugger. I can start the debugging process here. So debug console, or even the output where I want to look at. So now it's at the MPI init with the debugger. I can add breakpoints here anywhere in the code. Let's add a few more, I guess. And now I can jump through why actually read this. Anyone know how I can hide the top, like the audio or video buttons? Like I need to access this. If I hover over this, like the chat, but all those things, buttons are popping out.
I think you can move it with, there's like a 2 vertical to set the 3 dots, and you can move the whole thing somewhere else.
Okay, great. Thank you. Thank you, Daniel. So just like normal debugger, I can look at, I can add breakpoints and step through it. So I'm just gonna continue. So I'm here at the init state. So, okay, now I'm somewhere in the code. I have all these local variables that I can see here, and I can add watch. Okay. Okay. Yeah, so I can look at all the local variables and the registers and the stack and everything here. Suppose, let's say DT here, or even the TE. Let's consider TE0 or TE. I can actually select this variable and ask CoPilot. What is the value of TE0 and why is that? So this is, as I said, like this is kind of an experimental feature. So there could be a lot of bugs in here, but you can expect some good answers here as well. So it kind of it went through the code and understood the context, and it has access to all the stack, and then it can figure out like what the values when you're debugging, so it gave me an explanation what TE0 is and how it is being calculated. You can actually ask why this value changed from this to that. Let's say TE, why my value, if it changed to, let's say man or one, why you can ask CoPilot why it changed from this to that value. So since it has access to the stack and it is part of the debugger, you can actually get a pretty good answer out of it. Like I think Daniel raised his hand or asked a question.
Yeah, just briefly, I think on the response there, if you scroll up, it shows like the reference that you use. I was curious if you could click that, because I'm just interested, like, is this predominantly coming from the source code itself? Or is this coming from the documentation that Manyweather provided with it as well, which is included in the software repository?
I'm not quite sure, at least. So I think it is I think it is combination of both. If let's say like they're using for this, they're using some kind of a GPT model or like the Chat GPT model. If they had trained on the documentation of the Manyweather, it does consider that. Otherwise, it's just a context in here within the source code. If they have used and if it is using, I think the additional information will come here saying that like there's a license associated with the code or the information that you're using, and it will give you reference that you can include in your code as well. Does that make sense? Does that answer your question?
Yeah, I think I'm just concerned is one. Anyway, yeah, that answers my question. I was just thinking the some of those answers just might be dependent on the quality of like comments and like code documentation included in the repository, and so your results may vary with these sort of like questions depending on how well the code is documented.
Okay. Yeah. So now I can ask, since I know the let's say I copy this value, so I can ask here why t0 as the value. It's not like, I mean, the you can see the t0 is kind of wrong, but you can ask the same thing for dt as well. Let's ask that. Why dt has a value of 0.666. So yeah, as I said, this is kind of an experimental feature still, so you can expect it to improve in the future releases. Right now, it's kind of okay if you want to use it. And also, like, since we use more advanced debuggers or a licensed debugger, I don't know how to actually use CoPilot with that just yet. I couldn't find any information regarding that. Any questions before I move on to the next demo?
So I have a question. One question I have is that some of these codes are small enough that you can also test them. You are also compiling them on the login node. But I was overall like curious about like bigger code bases and how it would work with bigger code bases. Or like we should kind of like just like try to like subset the code to a smaller like kernel and then try to debug from there.
Yeah, that's one way to do that. Like you can actually ask the CoPilot to extract or write a unit test. You can ask to write a unit test to check the protection function in the code. It can actually extract and initialize with some kind of dummy data if you want that you can use debug. I mean, that's sort of like, as I mentioned before, like I couldn't find any information on how to use debugger plus CoPilot, external debuggers with CoPilot apart from the VS Code. So if they come up with something like that, like for example, like the linear one, like you can actually do some really good debugging by chatting with these, by chatting with the CoPilot. But that's one way to do it. Like you can test those functions to kind of figure out.
Sounds great. Okay, thank you.
Okay. The the next set of error I want to talk about is the runtime error. For this, I want to actually, I'll not be actually running any code because like I want to show a real problem that I fixed in Earthworks code, which will take like half an hour, 45 minutes to build. So I don't want to actually build it. I just want to show everyone how I tracked it down and what the error was. So we have this Earthworks code, which is essentially a version of CSM. We have the MPass die core inside CAM, and we are trying to run this MPass die core on GPU because it's been GPUized. So we have this interface called interface for using MPass with CAM. So when we are trying to run this, we kind of encountered this issue of just sec faulting because of this pointer particularly. So from the debugger and the error messages, we could figure out like this is the point, or this is the pointer which was causing an issue for us. So previously, if I search through this, oh, I have to just, So this was this pointer was kind of allocated in this function, and then it was previously deallocated using the deallocate statement. But for some strange reason, reason, we were getting sec faults, especially with this pointer. For days, we couldn't figure out like why this is happening. Looking at the code, like we should deallocate the pointer because we are allocating it inside the function. But this was causing a lot of issues, and we were like it took days to actually debug the issue. With CoPilot, I was able to easily debug it. It suggested me to actually nullify. It kind of looks simple fix, but it took us a lot of time to kind of figure it out without knowledge. But with CoPilot, it asked me to disassociate the pointer here. So with this, I was able to fix the issue pretty quickly. How am I doing on time, actually? Okay, 15 minutes more. So I had to speed up a little bit. So we were able to fix that issue pretty well. So it can actually debug other kind of sec faults as well. Let's say in a code, like if your indexing is wrong and if you're going out of bounds, it's just +2 here, and I can just try to build this. And if I run it, it should actually cause it did not. How is that? Okay, here. Rebuild. Maybe it's choosing some. Okay, for some reason it's building. When I tested before, it was actually causing an issue. So yeah, so if you have something like this, like where you're going out of bounds, we typically use a debugger to kind of figure out like where this is happening, and we look at the allocation and deallocation, and we look at the indexing to figure out if a particular variable is actually going out of bounds. But with CoPilot, you can actually just select the code, the whole set, and ask it to check here if you have any issues like memory out of bounds issue here. It can actually give you good enough answer. Like if it can recognize, like at least from my experience, it has been able to it's able to recognize some of the indexing issues pretty well even before I run the code. So you can actually debug and fix the errors in such a way that like using the CoPilot right here in the chat. So the next couple of errors, like it can help you track down missing libraries when you're building a big code. For example, if I unload the module here, module, oh, debug, okay. Unload parallel. Let's see here. It's not able to find the parallel CDF. I can just ask the CoPilot again. We're gonna ask explain. So it's kind of telling us like we are missing the parallel CDF. So how can I install? You can ask like further questions. How can I install parallel CDF? So it kind of gave you a well-structured documentation, a detailed step-by-step instruction on how you can actually build the parallel CDF or peanut CDF from scratch, and how you can use that in your environment. So this kind of thing is really helpful when you're working on large codes, right? Or suppose you want to build a custom version of MPI library that you want to use with certain GPU support. Let's say you're missing some libraries that you even after going through the recommendation, it's kind of producing issues. So you can ask CoPilot to give kind of detailed instructions. If you run into errors again, you can ask CoPilot again those questions. I'm running into this particular error when following the instructions. So it can actually correct itself and give you a better answer. It's kind of a trial and error with these things. So this kind of thing is really helpful when I was working on Python environments. Especially with the versioning of certain libraries which work together. If I switch a particular library to a latest version, which might not work in my environment, so it's kind of helpful for me to figure out which version I should use, and how to actually build that library with what options and other things. So yeah, very quickly.
Supreet, we have 10 minutes remaining, and I was wondering, I think you have 3 more examples that you want to show. Is that correct? Or 2 more examples that you want to show?
Yeah, 2 more. Actually, I'm just gonna skip the last one. I was thinking of, like, if I had time, I was thinking of building a small application from scratch really fast, like building a C++ application with all of these things. I can actually do with CoPilot. I can actually do all of these things within 30 minutes or so. So I was thinking of doing that, but I can actually skip that. And I'm actually towards end as well. So very quickly, I had examples to show, but since we are short on time, I'm just going to skip over these things as well. So by selecting the code, you can actually ask the CoPilot to see which memory layout is good for you. You can actually, like for C, you have the row major, and for Fortran, you have the column majors. Similarly, you can ask CoPilot, it recognizes the language and figure out like if your loop indexing is right, or how you're accessing the memory is right or wrong, or if it could be better. Again, you could actually track down memory leaks as well, which was really helpful for me in some of the codes. Yeah, it just looks at your allocate and deallocate statement, kind of figure out and tries to match them, and figure out if you have memory leaks in your code or not. So the next one is like you can actually validate your configuration by using assertion or logging or validation function, even before running your function, even before running your computation. Yeah, so again, I wanted to actually show, try to build a C++ application from scratch, which I have here. So I just built this application in here. I just created 2 directories, source and include, and I created this empty files, main.cpp, test1, test2, include, like, again, the same header files. And I asked CoPilot to set up an environment for me that I can use to build and run this code on VS Code. It gave me all the extensions and how I can configure along with task.jsons. Again, I wanted a make file, so I asked it to create by looking at the file structures for me. So it created a pretty good make file for me, although it had some issues, especially with the spaces and the tab. But it gave me a good starting point for me to build the code. Few more things, like I wanted to, well, I just wrote some codes in here and like just created few variables, which I can easily do. Like, let's say you have a equation that you want to implement and you have 5 variables. If you just explain it to the CoPilot, create A, B, C variables. I want to do this function. I want to implement this function, so it can actually give you a sample code, and you can actually build on top of it. You don't have to necessarily use the same thing. Again, to make the directory robust, I wanted to use Docker, CI/CD, and everything. All CoPilot did was it gave me a starting point. It gives me a starting point to kind of set up the directory and as well as the GitHub repository that I can actually build on top of it. So yeah, I wanted to show this demo. And again, summary, that's all. Yeah, well, to summarize everything, CoPilot is very robust in identify and suggesting suggesting things to try for you for your debugging purposes. It can actually significantly speed up the application debugging, at least just from my experience. A few things I want to caution is like, don't completely rely on CoPilot to debug your application. You have to pair it with a traditional debugging method to kind of give you a most optimized version right now. And it can give you wrong answers. So you can either adjust the prompt or change the prompt and give additional context to get a better answer out of it.
This is great. Thank you so much, Supreet. Yep, and one important point you mentioned is that sometimes the answers are not correct, or sometimes the answers are the most general answer that might not work, for example, on derecho or like, for example, there might be a better way to do things. So it's like not always 100% true. Are there any questions in the chat or online in the audience? I don't see any questions in the audience. I personally have a question. Would it be possible to give CoPilot some like additional context about the platform that it is running on? For example, like it's running on Derecho, and like I'll provide Derecho documentation to it as well, so that the material, the answers it provides would be based on Derecho documentations rather than just like, yeah, general answers. And the reason I'm asking this question was that one of the responses kind of like assumed for pnetcdf install, kind of assumed that the user has a sudo access. But it would be nice if we can like provide some sort of like documentation on the platform that it is running on.
Yeah, I think so. At least with the recent version of CoPilot, you can actually upload files here to give information about your code base, like consider entire all of your code base to be the context. Like I can just type code base and give additional information. I can also upload a file. Like let's say I have all the information about Derecho system or documentation about Derecho system here. I can just upload the file here and give it as a context. Think it should work. I haven't personally tried that, but yeah, I think it should work.
Yeah, that would be very powerful. That would be great. So yeah, thank you so much for that. Are there any other questions in the audience? If not, thank you so much, Supreet. These were great examples, and thank you so much for putting them together. Yeah, so the next session on the generative AI workshop is going to be on energy use and sustainability of LLMs. During December, we will send more information about the upcoming sessions soon. Thank you so much, everyone, for joining in today, and have a great day. Thank you.